What is the density of wet air with 75% relative humidity at 1 atm and 300 Kelvin? Given vapor pressure of water is 30 torr and the average molar mass of air is 29 grams per mole. Now we know that density is given by Pm divided by RT. We have the pressure, we have the temperature. What we need is the molar mass of wet air. Another thing which we have been provided with is the relative humidity, right? According to definition, relative humidity is basically the partial pressure of water, right, divided by the vapor pressure of water into 100. So if this is given to be 75%, we can say that partial pressure of water in the mixture divided by the vapor pressure of water, that is 30 torr, into 100 is equal to 75, right? So 75 into 30 divided by 100. This gives pH2O equal to 22.5 torr. So therefore the pressure of water inside the mixture of the complete gas is 22.5 torr. So if we have to calculate the mole percentage of water, we can say that it is 22.5 divided by what is the total pressure. It is 1 atm, right? We've been provided with this data. So that will be 760 torr into 100. And when you solve this, this comes out to be 2.96. So therefore, the amount of water is 2.96%. And so the amount of air, that is the dry air, would be 97.04%. That is 100 minus 2.96. Now, for the molecular weight of wet air, it can be considered as a mixture of dry air and water vapor, right? So we can say that the number of moles of dry air into the molecular mass of dry air plus the number of moles of water into the molecular mass of water will give us the total molar mass, right? So this is, for dry air, it is 97.04 multiplied by the molar mass is given to be 29 plus the moles of water are 2.96 multiplied by the molar mass of water, that is 18. And since 97.04 and 2.96 were in percentages, there'll be a divided by 100 term over here. And when you solve this, you get 2814.16 plus 53.28 divided by 100. And this gives us a 28.67 as the molecular mass. Okay. Now this is the molecular mass. Now we just have to plug in the values into the density expression and get our answer. So the density will be, pressure is 1 atm, the molecular mass is 28.67 divided by R is 0.082 into the temperature T is 300, right? So when you solve this using a calculator, this would give the density to be 1.164 grams per liter. And if we look at the options, we have option D matching exactly with this. So option D will be our answer.